All right, last session of the day. We try to save the best for last. Bank account insure full, Owen Smith from PayPal.
Yeah, thank you. Howdy. So my name's Owen Smith. I'm an engineer at PayPal. I am very much on the dev side of the DevOps equation. I've been working as a systems engineer in C++ for many years, and that means you're not going to get any stars of service acronyms in this presentation. We're talking developers, we're talking applications, and we're talking Puppet. So I want to give you some idea of what stuff we've been doing with Puppet. PayPal is pretty new to the Puppet game. We started full development with Puppet a little less than a year ago. And we've been working on it pretty continuously. This is going to be a bit of a report from the trenches, since we're right in the middle of our program to bring Puppet to the masses. So you're going to get give you some ideas of what we're trying to do with it. So here sets the stage. We have thousands of systems, and I won't be too specific on how many, spread across QA and production. Some of them are physical, some of them are virtual. Cloud is becoming much more of a thing for us. It's heterogeneous. And by that I mean it doesn't tend to be very large blocks of pools that look the same. It tends to be more small bits of pools that each have different sets of applications on them, and managing that becomes a bit of a challenge. It also means we're dealing a little less with pushing images around, a little more with getting packages to the right place at the right time. So we are primarily a Red Hat Enterprise Linux shop. So cross-OS support is not so much of an issue for us right now in the development side. Ops is a little more interested because they have to support all sorts of other wild stuff in production that developers are not directly concerned with. However, we do have applications in Java, in C++, and various other languages out there as well. So we do have to deal with that kind of extensibility when we're doing our deployment solution. Mostly what I've been doing is deployment. So it's the actual releasing our applications, getting them on the site, getting them supported, and that sort of thing. We got this? Yeah. So when we've been shopping around what we want to do in the deployment space, we definitely had to do a lot of work to sell the organization on what we're doing. This is the way we sell it. And this we could take to developers, we could take to managers as to why you would want to go through all the effort of putting Puppet in place, converting applications to work with Puppet, and all this sort of thing. First of all, be more reliable. Second, reduce waste time. A lot of stuff we do manually could totally be automated. And third, enabling new technologies and environments. This is really something that we're paying attention to, where we've been building these custom tools and stuff like that to support what we already have, but they've been point solutions that won't necessarily get us to where we want to be 2 years from now, 5 years from now, or even further than that. So that's what we're going after. And so the strategy to get there is full stack. So we want to take all these tools that people have been using to manage their OS, manage their systems, manage their platforms. We want to take that up to the applications as well and manage all our applications using configuration management. After all, they're packages, they have configuration, they can be managed. We want to use standard tools. There are places where we've done custom things and gone our own way some years before. We want to come back to the standards where we can. And we want to use tools basically the way they're meant to be used. That's a bit of a soft goal, and it's certainly subject to debate. And you may find a couple places in this presentation where you think, yeah, I don't know, they might have gone a little awry of that goal, but that's certainly a guiding star for us. And finally, we acknowledge that this isn't just a question of picking a new tool to play with. Although I'm a technologist, I'm an engineer, I love playing with stuff. But it's people and process as well. A lot of stuff has to change in that area. That being said, I'm going to ignore all that and just focus on tools for this presentation, and especially on Puppet. So here's what we're bringing in-house to help improve our deployments. We're doing Puppet Enterprise. I believe we're one of the largest Puppet Enterprise installations out there right now. We're using Huayra, which hopefully many of you have been hearing about in this conference. We're also bringing in MongoDB to help with the Huayra. And we're using Maven and Nexus to help on the Java side. So I'll get into each of these tools. First, Puppet Enterprise. We, of course, have many reasons to pick Puppet, and we have some reasons to pick Puppet Enterprise. I will say that choosing Puppet was not a foregone conclusion for us. It was something we arrived at after many months and maybe even over a year of wrangling with the fact that we have other configuration management tools, and we have people that are pushing big iron solutions, HP, Tivoli, other stuff like that. That being said, two things popped out for us as we were going through this. First was the familiarity. When I first learned about Puppet I was at PuppetConf 2 years ago in San Francisco. It was something where people in our ops organization pretty much knew what Puppet was. Not many developers in our organization had heard of it. These days, when I walk around the halls, I will occasionally get stopped by a developer who wonders if we could use this new tool they found called Puppet. And when I tell them, actually, yes, we're doing exactly that, they get really excited. So I've been noticing a lot more interest in upkeep around the development organization. So the word's getting out there, and it's not just IT people, it's not just ops people. And then culture. There's a question here, a certain tension about what we want to be as a company and what we want to be as a development organization. We're passionate developers. We are very opinionated. And we like open source tools. And we like the fact that we're built on Linux. And we have aspirations to be more involved in the open source community than we are today. So when we're looking at tools we could pick and the directions they push us in, we definitely felt that Puppet was pushing us more in the direction that we basically want to go. Now, in terms of why we picked the enterprise product, basically we pick up two things for that. Number one, full stack works right out of the box. We could get to the business of actually working on our applications. And believe me, we got lots of work to do on the applications. So, secondly, support. It's been really nice to have a place we can go file tickets and stuff like that, even above and beyond what you would normally get by being a part of the Puppet community. So we have we have Puppet Enterprise, and we have Huayra. Huayra, as you hopefully know by now, is a Ruby library. It is managed by Puppet Labs, and there's a plugin that comes with it, so you can plug it right into Puppet. It provides a hierarchical key value lookup. So a lot of our configuration data, of course, is in keys, values, pairs, and the values could be strings or lists or hashes. Huayra makes it really easy to manage all this. And it makes it easy to manage it in a way where you can say, give me a value for a particular box, and it'll look to see if it has a value defined for that box. If it doesn't have it there, it'll look in the pool. If it doesn't have it there, it'll look in the data center, and go on up the list until it finds a value that it likes. It's pluggable in the sense that you can put multiple backends in, and we're using multiple backends, as you'll see in a bit. And it's playable in the sense that it's really easy to configure. It has a nice configuration file. You can easily configure it with a Ruby hash directly if you want. And you can configure that to add new levels. So if you need to extend your hierarchy for whatever reason, it's pretty straightforward to do. So we like that aspect of it. And we've managed to find some uses for Huayra that you may not have seen before. So before I go on, though, I want to pause for a minute and ask the question, why would you want to manage with a hierarchy? This is something that's been interesting to me. PayPal has been using hierarchies of various sorts over the years when we're doing our application configuration, when we're doing our systems, not necessarily talking the same language everywhere we use it. But there is some element there that's proved convenient for us over the years. Some of the obvious things that you get. If you're dealing with nested groups of infrastructure, and we at PayPal certainly are, it maps well to a hierarchy. So I can take a pool of machines, I can say that pool is now something in my hierarchy, and I can manage things at that level, and they'll automatically apply to all the boxes in my pool. Hierarchy also gives you a clear order of preference. So if I have two possible values, one that I specified way up at the data center level, one that I specified down at the machine level, I want the more specific one to take precedence. And the hierarchy gives me a natural way to express that, so I don't have to build a bunch of conditional logic. And I've seen conditional logic spaghetti nests floundering around in our code where we didn't have nice, clear rules for how these things work. So what this all gives you is the ability to specify a configuration in one place, have it apply across a large group of systems, so you can be quite expressive with it, and you get the ability to specify exceptions where you need exceptions. And there are always exceptions. So this is all good, but it comes with some drawbacks, and we definitely hit some of these. Let's take OS. Now, if you see some of the hierarchy examples that I've seen earlier in this conference, you'll see that OS is sometimes mentioned as a, well, you can actually put that in and make that a level of your hierarchy that Huayra will go look in. But if I'm dealing with I've got data center pool machine, where does OS fit? Do I want to have an OS default that maybe a pool can override? Do I want to have a data center default that maybe a Solaris box in that data center would override? It doesn't, it's kind of on a different axis, so it makes it a little difficult to figure out what to do with it. And so you might ask the question, well, how about I put it in both places? I'll have an OS pre and an OS post. And I've seen that at PayPal, and that way lies madness. So you just have to accept that certain things may not fit in your hierarchy the way you want them to fit. Another thing, let's say I have a pool over here in QA. I have a pool over here in production. And I want them to basically look the same. They want the same applications. Well, how do I do that? I can't express it by pulling the configuration up in the hierarchy, because then I'll be adding all these classes to other parts in the middle that I didn't want to muck with. So I basically am stuck with copying and pasting. I take a bunch of classes over here, cut them, paste them over here, copy and paste. And I've broken the don't repeat yourself principle that I was sort of striving for when I was using this hierarchy. I've lost some of that expressivity. So there are trade-offs when you're doing this. Not everybody needs to do hierarchy necessarily the way we've done it. But for us, we have gained some benefits by choosing the hierarchy, and we're going with it. So where are we doing with Huayra? We use Huayra in a bunch of places, actually. We've kind of gone whole hog with the Huayra thing. We have actually made a modification to the library to support one thing we wanted to do. And that was Huayra has rules for how it resolves conflicts when it sees a value in one place and it sees a value in another place. If it sees strings, it will just override and give you the first string it finds. If it sees lists, it will merge them as if you were doing a set union operation, which is really nice if you've got a group of classes here and a group of classes here, and you merge them together and you get a nice group of classes. For hashes, it will merge the hashes together, but the values will override. And what we wanted was actually the merge to go recursively into the values of the hash. So if I have a hash of hashes, I want all those hashes to be merged too. And the reason we did that was for class parameters, so that I could do some partial specification of class parameter defaults at a high level in my hierarchy, and then I could provide other partial specifications of class parameters further down the hierarchy and merge that all together to get a complete set of parameters for my application. When we start talking about doing data bindings in Puppet 3.0, the meaning for this may be a little less than what we have right now, but that's where that came from. We use Huayra both the YAML form, and we use MongoDB as a backing store. There is, I believe, a plugin already out there for MongoDB. We tweaked it to support sharding, which we're doing right now in production. And then we use it both on the external node classifier, and there we're using it directly as a Ruby library. And we use it in our classes where it's being plugged into Puppet through Puppet functions, and also through Puppet functions that we've written ourselves. OK, MongoDB. For those of you not familiar, anybody not familiar with MongoDB in the room? Are we all kind of with it? OK, one person, I'll say. It's a document-driven database, so it's a little bit different from your standard relational database. And the documents are JSON structures. I could take a hash of stuff, which looks like a JSON structure, throw in the database, quick key value lookup, and I also get the ability to query things inside the structure if I need that later on. But for what we do with configuration data, where we have keys and values, and the values are often simple things like strings, this kind of structure is perfect for what we need, and Huayra works well with it, except for one thing, which is if your configuration keys contain dots. A dot to MongoDB is a very special meaning, and it means nested structures. So you'll have to figure out how to munge the dots or do something like that so that you don't confuse MongoDB. So Maven and Nexus. Like I said, we do use Java, and we have a kind of large contingent of Java users. Maven is a very popular open source Java build deploy test tool. I'm a C++ guy, so I think of it as make on steroids. Nexus is an artifact server, and it's usually storing jars or wars that that Maven has published. We already use this at PayPal in development, but when we got to getting stuff to production, we would take stuff out of Nexus, repackage it as RPM, and start managing it as RPM. And the feeling was, from various architects and leaders in the organization, how about we go for a Java native solution across the board? And what we do in development, we do the same thing in QA, we do the same thing in production. Could we use MVN deploy everywhere? The answer is yes. Puppet allows you to do a whole lot, but it leads to some difficulties. So I'll get to that later. So that's sort of the scope of the tools that we selected to implement. And we're using this for our full stack. So let me show you a bit how it comes together. We do use an external node classifier, so what I'm going to walk through here is kind of how we structure our infrastructure, how we get that data into the external node classifier, and how Puppet will run with it. So the system hierarchy for us looks a little bit like this. In this case, I'm showing you what the setup would be for a test environment. At PayPal, all test environments are just called stages for historical reasons. We have various levels of them. At the top, we have environment, then geographic region, data center, stage, pool, and down at the bottom, a host. So here you would be seeing the setup for, say, 6 boxes divided into 3 tiers, and it's going to be front, mid, back, and other stuff like that. We have a data store, it's kind of separate from the Huayra stuff we do, called a system catalog, which stores these hierarchical properties of where a system lives in the hierarchy. And it's just a quick lookup. Whenever we get a host name, we'll go look up in this catalog and figure out what is its env, geo, DC, stage, and pool. We also make those available as facts through Factor's external facts mechanism. And the reason for that is so that M Collective can get its hands on this goodness as well. So now when I want to do deployment to a stage, I can basically twill some stuff in Huayra. I can kick Puppet by saying, hey, M Collective, go run Puppet on everything matching stage equals stage 9. And I'm done. And so having the hierarchy to be able to be used in my configuration, also exposed to my orchestration, is really nice. So once you got this hierarchy set up, you want to start doing things with this. So we'll start assigning things to our hierarchy. This is where we'll start using Huayra, and I'll show how in a bit. But first, let me get some concepts out. In addition to doing classes, there's some new things that we've introduced. So first is the concept of a role. And I know there are various other people doing some variant of this as well. Remember when I talked about this problem of I have a pool over here and a pool over there, and I want to make them structurally look the same? It's a bit of a pain to do that if you've got a long list of classes. And it's easy to miss one, it's easy to get screwed up. So what we do is we create an entity that just groups classes. And it can also contain subgroups as well, sub-roles. So that is what we call a role. And we assign it to usually a pool to say this is what stuff in this pool is supposed to look like. The role is given a name, and then when we want to assign the role, we assign that name to some particular construct in our hierarchy. In our case, we only allow one role at a time. So when I look for a box and say, hey, box, what is your role? I get one answer. And then I will take that answer and expand it in the group of classes that I want. So here, I'm showing 3 roles. One for front tier, one for mid tier, one for back tier. 2 things going on in the front tier, 2 things going on in the back tier, 2 things on the mid, 1 on the back. These are all classes. So I haven't said anything about how I'm implementing these things. I'm dealing with it at the Puppet level of abstraction, which is nice, as you'll see. The next part is, once I figured out what goes where, and the structure of my infrastructure is, now I want to talk about versions. In the application space, versions are very important. You're often being quite exact about exactly what versions you want, and it's not necessarily one consistent set of versions across the entire site. You have multiple reasons to be having different versions in different places, and we needed some way to get our head around all this stuff. Historically, what we've done is just push changes out the door, push, 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 and at the end of the day, we don't really know what versions we were supposed to have, and if something got dropped mid-sentence, and we see 2 boxes with different versions on them, it's been difficult for us to know which one was right. So this helps us solve that problem by giving us an unambiguous description of what are the versions that are supposed to be out there for a particular thing. So this is a complete set of packages. I'm just showing the ones here that apply to our example, but normally this would be hundreds of entries. And it has the packages versions for each of these. Some of these are RPMs. They would be created and published in a Yum repo, which we will use to install. Some of these are Java artifacts, which would be sticking in Nexus. And some of these are application configuration packages, which are also in our world RPMs, and I'll talk about that in a bit. I create a construct, this label. It has a structure. It's just hashes. It looks literally, you could use YAML if you wanted. And then we assign that label. In our case, we maybe want to assign it to stage 9. And by assigning a label up there, we've instantly guaranteed that all the boxes in our box will get the same versions of stuff and will be consistent. So for setting up a test environment, this is great. And it makes it easier for us to support these multi-box test environments, which are becoming more common. So where do I do all these assignments of roles and labels? I do it in a hierarchical data store. In this particular case, it's a Huayra instance in MongoDB. We've got multiple Huayra instances, so I have to keep track of which one is which. This one we call system Huayra, since it has all the basic facts about our infrastructure and describes at a high level what's going into our infrastructure. The hierarchy looks a little bit like this. You'll see a bunch of percent brace stuff. So those are the hierarchical properties that I got out of the system catalog. This is specifying how they'll plug in when I go to look for values. And you can see I start with the system, then I look in the pool, then the stage, then the data center, and so on. I'm using nested directory structure here. And the reason is so that I can have hierarchical properties that are not unique for a particular part of the hierarchy. So if I have, let's say, a pool called front over here and a pool called front over there, I'm not going to get confused about which one is which, because I'm always using a path to refer to the configuration for that construct. It's not the only way to do it, but this is the way we chose. The collection that we use is called sys-Huayra. You can have more than one collection as long as you're keeping your Huayra objects separate. And this will ultimately be used to construct a Huayra object. You'll notice here I'm not doing this with Huayra.yaml. This is actually Ruby code. And you can just take Ruby, build yourself a hash, and throw that straight into Huayra to initialize it if you wish. And so this is actually code that we have in our external node classifier, which is written in Ruby. So here's what some of the data looks like when we put it in. At stage 9 level, I might assign a label, and it's just the name of the label. The actual data of what goes into that label is stored elsewhere. Again, for roles, I'm going to describe the name of the role. The definition of those roles lives elsewhere. And then I also have the ability to add classes. So this class structure looks very similar to the class structure I'd be returning from my ENC. So the reason we support that here is so that I could throw on an additional class to test if I want. Normally, I'd want this stuff in a role. For QA, for development, it would be a bit of a pain to have to create a new role every time I want to tweak something. On the production side, we anticipate that we want to be a bit more specific about using roles consistently. And then what I'm not shown here is that we also support parameters. So I can assign global parameters if I need them, and they'll be available in Puppet as global variables. And they get merged through the hierarchy just like anything else. So I can specify defaults at the environmental level and get down to overrides for a specific box. So putting this all together, this is what the external node classifier looks like. And it's actually very simple code once you put it all together. Huayra makes a lot of this stuff real easy. So we grab the system properties from the catalog. We get the set of classes for the system. So we're going to take a role, blow that up, add classes to it, get the label, expand that into a hash. That actually becomes available as a global variable in Puppet. And this might raise some eyebrows, because you're thinking, well, this is all versions for everything, and every class now has access to this because it's a global variable. Isn't that kind of ugly? And the answer is, well, yes, it's a problem. But what it allows is that the ENC doesn't have to know which class is installing which packages. So I'd maintain my class encapsulation. That, to me, was more important. And so that's why we went that way. So we got the label data. We've got parameters. And we actually add label data as a parameter. And then once you've got all that, you just spit it out as YAML, and you're done. As ENC doesn't need to be super complicated to get serious work done. On the application configuration side, one thing I'm running a little out of time here, so I'll just touch on, we decided to actually go with Huayra for application configuration as well. We use YAML files for this, and they're stored in the application source code repo. Not in the Puppet modules repo that we have, and not directly on the Puppet masters. And the reason for this is in our organization, developers own, for the most part, the application configuration. Yeah, ops plays some role, but mostly there's a tight coupling between the application and the configuration that comes with it. It didn't make sense for us to have these in 2 different repos and have to sync those repos up, sync up their branching models, and all the pain that comes with that. So what happens is when we go to build our applications, we'll publish 2 packages. One's the application, that goes to the endpoint. One is the configuration, that goes to the Puppet master. And we use a simple naming convention to figure out which is which. And then once you've got all that stuff, it does have to be versioned. So because I've got a central Puppet master serving up a bunch of QA environments, Each one of them may want a different version of configuration. I use version directories to put them side by side, and I will pass through the label data to the class the version of configuration I want it to use. And from there, I can load up Huayra. I can ask Huayra for the keys and values for that particular system. I get that out, and I can generate my config file from there. All right. On the Java side, how did this Maven experiment work? Well, the nice thing is with Puppet, you have a class that you're working with, abstracts all the details. So somebody working with deployment at the class level doesn't care whether they're deploying a C++ application or Java application. They're just adding a class to a system. That's great. And it's very much not what we have to go through today in the pre-Puppet world. To do this actual stuff, we have this nice package resource. And we figured, well, how about we write a custom provider? Well, that'd be nice. So we'll just have the custom provider run mvm deploy, and we'll be done. No, not so fast. For the package resource to work correctly, you need all the properties of idempotence. So Puppet needs to be able to figure out what version of this thing is already out there. Am I out of date? How do I get up to date? How do I upgrade? How do I downgrade? How do I remove? Basically all stuff that Maven doesn't know anything about. Maven knows how to throw something onto a container, doesn't really know about how to manage it once it's thrown it out. So yes, you could build this stuff into Maven. We decided to build it into Puppet. So basically, we ended up writing a mini package system. And I know there was a talk yesterday where somebody said, if you're writing a packaging system, you're probably doing something wrong. So I think the jury's still out about whether that's really the right approach we want to take. Maybe we'll go back to RPMs, or depending on how the Java folks like this, we might actually finish it off and open source it. So I could see us going either way on that at this point. And then one other optimization we did, which is being kind of cute, is we decided that we have a bunch of servers in Java that all share a container, they all share jars in common. Wouldn't it be nice if I could just download those once instead of having to download them as part of some embedded WAR for every single server? So instead of having the Maven artifact that we grab be a WAR, we have it be a what I call an installer. It's just a pom.xml that we can use to assemble the server that we want on that box. And so some of that assembly is happening on demand on the endpoint. Testing. If you guys are not doing continuous integration testing, you should be. And it's very clear to me after seeing what our group went through before we had this stuff. Jenkins is what we use at PayPal for this sort of thing. It's a fine tool. And what it has is the ability to write a custom build script and stick it into some random Jenkins job. So it's super easy to customize it to whatever you want. So we have two tests. One is a basic test of our Puppet modules. We do syntax checks on the Puppet modules. We do syntax checks on the ERB files. You can compile them to Ruby code and then syntax check that. And we run unit tests. If all those pass, we publish the Puppet modules RPM. Great. And yes, we do use RPM for deploy. Some people use Git. That's fine too. Second, test deployments. Since we're dealing with applications all the time, we have a dedicated environment with a Puppet master and an endpoint. And basically, we're repeatedly setting up the Puppet master, wiping the test endpoint, and then running our deployment with whatever Puppet modules we have, bringing up services and seeing if they start cleanly. There's no reason you couldn't also do this with Vagrant, spin up a test environment on demand to run this test, or use whatever cloud provisioning strategy of choice you want. So those are things maybe we'll do in the future. So where are we at? Well, the first thing we did actually had nothing to do with applications. We just started by managing subsystem packages and their versions, since that's relatively straightforward to do in Puppet. Immediately found packages missing, packages out of date, packages ahead of date. And so it yielded early fruit very fast. Then we went through the application stuff. There's a lot of work we've been doing conversion. Right now we're in QA on that. And we've got things running pretty well thanks to the continuous integration. Continuous integration has sped us up quite a bit. And at least for me as an architect, I love seeing the daily reports coming in and knowing that at least something out there is doing work. And then we've been collaborating with Puppet Labs. There was one problem we had where some of our deployments can take anywhere from 30 minutes to hours if we're trying to do a full install of packages and we got a bunch of packages to get through. In the meantime, Dev and QA are twiddling their thumbs, and Puppet is only too happy to tell us whether it's succeeded or failed after it's done. So we worked with them, the consulting group at Puppet Labs, And they developed a real-time status feature for us where Puppet will send back ActiveMQ messages as it's going through its resources. We have a listener that's listening to those and updating our deployment status so that at any point our QA people know where they're at in their deployment. And the other thing I'll note is that we've started to make more contacts within the larger eBay group. PayPal is a subsidiary of eBay. There are at least 5 people I've talked to across the organization who are interested in Puppet, and there's been some pickup. Some of them I actually even bumped into at this conference, so that's been really cool. And I think that speaks well for the viability of Puppet as a product. So, some of the design challenges I'll leave you with. Do you want your infrastructure to be code or data? We're not quite sure on that one. I really like classes. I really like the fact that I can put conditional logic and other stuff in those classes. But every once in a while, somebody will come to me and say, you know what I really need to know is what packages are being deployed by that class? What services are being managed by that class? Can I reach into the class and pull that information out? Can I go to PuppetDB? Can I go to like reports? Can I get that information before Puppet even runs? And once you start getting to that, we lead down that path to how about we create our own little mapping on the side, a little hash of here are all the classes we have at PayPal, and here are all the packages we have at PayPal, and here's how we map between them. I'm really, really pushing hard on that. That really makes me cringe. But some of these things can get difficult. And some of these things, it may just be we're like, look, run Puppet once, then we'll go to PuppetDB and pull whatever you need. Dependencies. In the application space, more so I think than in the system space, we manage the packages and we manage the Puppet code. So there's a lot of flexibility about where you want to do things. Do you want to do them in Puppet? And we like Puppet a lot, so actually there's a lot of temptation to do that, maybe even times when we shouldn't. Or do you want to do something in RPM? The big one for us has been dependencies. Do we want to have dependencies up at the Puppet level? Do we want to have them down at the RPM level? And the problem case there is one application with config depends on another application with config. If we have just RPM, we can bring the app along with the package fine, but we'll be missing its config, which would be disastrous. If we do stuff just at the Puppet level, we're missing some of the features that you get out of RPM dependencies, like dependencies on abstract capabilities or files, executables, shared libraries, and even versions. So, and then the third possibility is both, which is somewhat redundant and makes us think twice anyway. Third, I've noticed a tendency for us to want to do different things with Puppet depending on what context we're in. Some of this stuff is just, I need to do a no-op run to see what Puppet will do. Great, we got that covered. I need to run a subset of my stuff. Config file only runs. Great. We can use the -- tags feature for that. Just run our reconfigure and we're done. Service control. Something kind of weird for us is that we do service control as an entirely separate operation from the rest of our Puppet run, and we don't want there to be any possibility for services to happen during a regular Puppet run. Can't really solve that with tags. If somebody were ever to run Puppet that didn't involve tags, they would be getting everything with it. So the way we solved that was with a standalone manifest. So it's not a great solution. But there have been cases like this where you find as you're going through this that this is a problem that you have to contend with. What exactly do you want out of Puppet, and how are you going to get it to do what you want? Faces helps with this, I think, and we'll probably be playing a bit with faces in the future. And that's what I have to say. So questions? Put the house to sleep.
Thank you very much.
OK, thank you.
Achievement unlocked. You've made it to the end. Check Twitter, hashtag PuppetConf. There's a GitHub meetup going on at Zeke's at 8:30. There'll probably be other stuff going on. Check the intertubes. Information will flow freely, as presumably the alcohol will, that is presumably graciously provided by GitHub, and not us. I'll see you guys there. Thank you for coming.